Okay, in our final review of factoring and working with factors, we're going to talk about the quadratic formula. Not every polynomial factors nicely. So, if I have something like, say, 3x squared plus 5x plus 4, well, that's actually going to work out okay. So let's do plus 3 equals 0. I need to solve that. Let's say I have something like that. And we start trying our magic numbers. Let's stick with times on top. Sorry. My product would have to be 9, and my sum would have to be 5. But when I look at the factors of 9, the factors of 9 are 9 and 1, and 9 plus 1 is not going to give me 5, or 3 and 3. And 3 plus 3 is not going to give me 5. So that doesn't factor. So when it doesn't factor, what other choices do I have? Well, the other choice that we have, there are a couple. One's called completing the square. You'll learn that in Algebra 2. But the other choice that we have is called the quadratic formula, which is something you learned in Algebra 1. The quadratic formula looks like this. Negative b plus, actually it's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now you may have learned a little song to go with that. You may not have. I don't know. I'm not singing it for you today. But that is the quadratic formula. And that automatically gives us our solutions to this polynomial situation without factoring. Now these solutions are usually not nice numbers. They're fractions, they're square roots, they're all sorts of funky things, which we could approximate decimally if we need to, but we don't always. But it all comes from the coefficients here of a, b, and c. So if we're going to use quadratic formula, if things will not factor, we set up our quadratic formula. First we identify a here is 3, b is 5, and c is 3. So negative b would be negative 5 plus or minus. So one solution is going to involve plus, one is going to involve minus. The square root of b squared minus 4 times a times c. All over 2 times a. Now, remember, it's important to realize the whole thing is over 2a, not just the negative 5, not just the square root. The whole thing is being divided by 2a. We then simplify that. That's negative 5 plus or minus the square root of 5 squared is 25. 4 times 3 is 12 times 3 is 36. All over 6. And I get negative 5 plus or minus the square root of negative 9 over 6. Oh dear. I don't know how to take the square root of negative 9. If that was a positive 9, I'd be great. But a negative 9, that leads me to problems. Problems that I will be able to solve in Algebra 2, but for now, we'd look at it and say, because I cannot simplify the square root of negative 9, there are no real solutions. Now, the word real here is important because there are solutions. They just aren't real numbers. They're complex, what we call complex numbers. We're not going to teach about those right now. But we do get solutions that are complex. All right? Let's try another one. Let's make up a polynomial that's 7x squared plus 6x minus 2 equals 0. And let's solve this using the quadratic formula. It may have nice numbers, it may not have nice solutions. Let's find out. First we identify a equals 7, b equals 6, and c equals negative 2. So my formula, negative b plus or minus the square root of b squared minus 4ac all over 2a comes into effect, and I plug my numbers in. That's negative 6 plus or minus the square root of 6 squared minus 4 times 7 times negative 2 all over 2 times 7. So we plug our numbers in. Then we simplify. Negative 6 plus or minus the square root of 36. Now, negative 4 times 7 times negative 2, I've got a negative times a negative. It's going to be a plus. And 4 times 7 is 28, times 2 is 56, all over 14. 36 plus 56 is 92. Now this we can actually simplify. I know you're saying, wait a minute, but what do we do with that plus minus? Really what we're doing is we're splitting that now. We're going to do negative 6 plus the square root of 92 over 14 is one solution. The other solution is negative 6 minus the square root of 92 over 14. And for now, we're just going to approximate those decimally. In fact, in a lot of cases, we could just leave our answer right here. But if we actually needed decimal approximations, we do that in our calculator. We have to be careful, though. When I'm doing this, I want to put this in parentheses in my calculator. Okay, so parentheses, negative 6 plus the square root of 92. And close those parentheses before you do the division by 14. And it's about 0.256, about 0.257. And then we get negative 6 minus the square root of 92 and divide that by 14. And it's negative 1.114. So those are the values of x that make this equation true. It's not pretty. The solutions are not pretty. They're weird decimal radical values, but they are the solutions, and we can solve it. I don't think you're going to see a whole lot of this in your geometry class, but it's a good, solid review for Algebra 2, knowing the quadratic formula. Let's do one more for today, and then we'll call it enough. You can always rewatch examples if you want. Negative 3x squared plus 5x plus, I don't know, let's do 5. Let's not do 5 because I already did 5. Let's do 7 equals 0. Okay? If I wanted to try to factor it, I probably could. Product is negative 21, sum is 5, and nothing's going to work. So we identify A equals negative 3, B equals 5, C equals positive 7. So positive 5 and positive 7. So negative B plus or minus the square root of B squared minus 4AC over 2A. Opposite of positive 5 is negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times 7 over 2 times negative 3. That's plugging the numbers in. Now we simplify. Negative 5 plus or minus the square root of 5 squared is 25. That's 21 times 4 is 84, so plus 84 over negative 6. So that's 109, negative 5 plus or minus the square root of 109 over negative 6. And again, if we needed a calculator estimate of that, we could, but those are my two solutions. It's not pretty, but we can find the solution for any polynomial. All right, so there's quadratic formula. Again, I know a lot of you had trouble this year just with distance formula and slope formula. Quadratic formula is definitely another step up in complexity, but memorizing formulas like distance, slope, midpoint, quadratic formula, things like that, that's an important part of your learning process. Learning how to memorize and apply formulas. So this is one you probably do need to know at some point, especially when you get into Algebra 2. So make a note of it, put it on a note card, quiz yourself, make sure you get all the numbers in the right place, make sure you get the entire denominator is over, or entire numerator is over 2a. Okay? It's not just the negative b that's over 2a, it's not just the b squared minus 4ac over that's 2a, it's the whole thing. So keep that in mind, keep working with quadratic formula, and good luck with it.